Hi everyone. Today's lesson is on function composition. If we were together in class, I would probably dive more into the meaning of the word composition. But just know that when I'm talking about composing two functions, really what I'm talking about is applying one function to another. Okay? That's what the process of function composition is all about. It's taking the process of one function and applying it to the result of the process of another function. Okay? Sometimes I hear people use the word combine here, and that's not false. I mean, it is combining two functions, but we just want to be careful that we understand that we're not just smashing two functions together. We're actually putting like one inside the other. Okay? So just to talk notation real quick, because there's two types of notation you're going to see that mean the exact same thing. And it can look a little confusing with all the parentheses and all of that. So we all know our regular old function notation looks like this, f of x, right? If I wanted to then apply another function on top of that, I would just put that function on the outside here and then put the f of x in parentheses. So this is read g of f of x. That's how I would say that. G of f of x. Okay? And when you're reading these things, or when you're applying these things, I should say, mathematically, you start on the inside. Okay? So we're going to start with the f of x here. Now, this is a totally correct way to write this, but some people don't like all those parentheses, so they've come up with another notation here, where instead of all the parentheses, they just use this small circle, like that. This means the exact same thing as this, okay? You're still starting with f of x, you're just applying the g function after that, and you'll see that notation if you look down at example 1. You can see what I'm talking about. And it doesn't always have to be f and g. I mean, we're used to using f for functions, right? But depending on the situation, we may be using totally different letters, but that's the idea. So when I look at this example 1 here, I'm given two functions, f of x and g of x, okay? And so starting off nice and easy here, f of 5, we all know, means to take that 5 and plug it into the f function. So this would be 3 times 5 minus 2, so that's 15 minus 2, which is 13, okay? And so this is my way of saying that under this function, the 5 is matched up with the 13. So when I see something like this next one, g of f of 5, I'm still starting on the inside here with f of 5, okay? So if I hadn't already figured that out, that would be the first thing I would do, is I would go ahead and calculate f of 5. Now, I just did that a second ago, so I just know that f of 5 is 13. But if I had to, right now I'd be plugging that 5 into the f of x function. So now what's really happening here is we're taking this f of 5 in our heads and replacing it with a 13, okay, because we know the answer to f of 5. So this is now asking me for g of 13. Okay, and g of 13 here, let's see, that would be 13 minus 4. And 13 minus 4 gives me 9. Okay, so there's my final answer on that one. So that means if I take the 5 and apply the f function and then apply the g function, the final result would be 9. Okay. Something I should probably point out here, and I'm trying to look ahead and see if I have an example that shows this, but this process is not commutative. And if you don't remember what the word commutative means, the easiest example would be like either addition or multiplication. So with addition, if you add 2 plus 3, it's the same as 3 plus 2, okay? If you do multiplication, 2 times 3 is the same as 3 times 2, okay? But with this, doing g of f of 5 is not the same thing as doing f of g of 5, okay? if you apply the functions in the opposite order, you get a different result. All right, so you can't take any shortcuts here. You have to apply it in exactly the order that it's given to you. Okay, in fact, I might get rid of this g of f of 0, and maybe we'll do just that. Maybe down here we'll do f of g of 5, just so we can see that play out. Okay, so in this example, if I'm doing f of g of 5, I would start by calculating g of 5. Okay, so off to the side here, I'm going to go g of 5. Well, that would be 5 minus 4, which is 1. I got that from right here, right? G of x is x minus 4. And so now I want to do f of 1, and I get 3 times 1 minus 2. Well, that's 3 minus 2, which is also 1. That's a coincidence that those came out the same. But notice my answer that I got here, my 1, is different than the answer I got up here when I started with the f function. Okay, so doing f and then g or g and then f does make a difference. Okay, all right, I think I've said enough on that point. So here's that other notation. Okay, that f of g of negative 3, but remember this works the same way, and we're still starting with this. We're still starting with g of negative 3. Okay, so g of negative 3 would be negative 3 minus 4, which is negative 7. And then I'm applying the f function, so I'm going to go f of negative 7 is 3 times negative 7 minus 2. Negative 21 minus 2 is negative 23. Okay, so I think you're probably by now seeing the process and how this is supposed to work here. Okay, so these next two, notice they don't give you a number to work with, they just give you x. Okay, this is when we're creating a big like hybrid function. I am taking the entire g of x expression and plugging it into the f function. So looking up here, I am taking the g function, x minus 4, and putting it in place of x in the x function. Okay, so that's going to look like this. My x function would be 3x minus 2, but instead of x, in parentheses, I'm putting in x minus 4 minus 2. Okay, and now I'm going to go ahead and distribute. So let's see, that would give me 3x minus 12 minus 2, which really simplifies to 3x minus 14. Okay, and so that's my new function. That's like a new function based on the other two, that if I was to apply these two together in that order, it would always end up working out as 3x minus 14. So like if I look up here, this was also f of g of 5. If I had plugged 5 in here, this function would just spit out that final 1 as my answer. Okay, so you can compose the two functions. I mean, if I was having to do a lot of these types of problems all in a row, I might want to go ahead and come up with this new function first, and then that just combines these two steps for me. Okay. This one here, g of f of x, that's just having us go the other way. And remember, we're not expecting it to come out the same here. Okay, so take f of x here and plug this in to the g function. So up here, I'm taking this and putting it in place of x down there. So really, that's going to look like this. Instead of x, I'm putting in 3x minus 2, okay, minus 4 from that x minus 4 there. And then really all I can do is combine these two. So 3x minus 6 would be my g of f of x function. And again, if I look back at this one, if I plugged in a 5 to g of f of x, okay, 3 times 5 is 15 minus 6 would give me that 9. Okay, so let's try it with a couple more. These are different functions now. We've got m of x and p of x. Okay, so why don't you go ahead and try, and if you need to pause the video, you can, but go ahead and try to do that first one, m of p of negative 4. Remember that we're really starting with the p of negative 4 piece. Be careful here. So you're plugging that in to x squared. So that would be negative 4 squared. Don't forget your parentheses if you're going to use your calculator on that, because it should be positive 16. And then we want to bring that down here and do m of 16. That would be 16 plus 5, which is 21. Okay. Go ahead and try the next one. P of m of 1. Pause the video if you have to. Start with m of 1. That would be 1 plus 5, which is 6. And then apply the p function. So now I'm going to do p of 6. That would lead me to 6 squared, which is 36. Okay. And then here are where you're combining the actual functions. So maybe take a second and see if you can combine the functions in this order. Okay, so this one is saying take the m function and plug it into p. This one is saying take the p function and plug it into m. So if I plugged the m function into p, I'd be taking this x minus 5 and putting it in place of x over here. So that would really end up looking like this, x plus 5 squared. Now, a lot of the times I'm going to make a big deal about you simplifying these. So like up here, we wanted to clean this up, right? And we simplified. This is pretty well simplified. Okay, we could FOIL this if we wanted to, but this is just as simple. Okay, so we can leave that one alone. And then to take p of x and plug that in over here, really all that's going to happen is that x is going to turn to an x squared. So we're going to end up with x squared plus 5. Okay, but again, just to remind you, there is a difference between this and this, a pretty significant difference between them. Okay, that's really all I have for function composition. There is another page there that you're going to do as kind of a guided practice activity. I'll put some instructions in Blackboard for that, but this is it for your notes for today. Please go ahead and attempt the homework assignment tonight, which is Lesson Master 8.1b. There will be some questions on there regarding domain and range. I'm intentionally not covering those here because I want to see you try them. I will be looking to see that you attempted them on your own first and thought about them first before we talk about them as a class. Okay? All right. Have a great day.